Hi, my name is Sarah Tashnik, an application engineer at Materialize. In this tutorial, I'll be going over how to eliminate holes in your 3D models in 3Matic. In this tutorial, you will discover common causes of holes and false connections, how to isolate holes, and how to fix holes. A common problem that I see in a lot of 3D models are holes in the surface and false connections that shouldn't exist, therefore are anatomically inaccurate. Here you can see an example of a hollowed heart model where there are multiple holes between the right atrial appendage and the aorta. With this example, these holes don't actually exist in the patient. And we obviously want to have a model that is true to the patient's anatomy. In this video, I will show you how to fix these holes using tools within 3Matic. But first, let's discuss some of the root causes of these holes and false connections. I am going to discuss two primary causes. The first cause is over-segmenting in that region. I am going to hide the hollowed model and look at the blood pool that we used as input for the hollowing. We can see that there is a false connection between the right atrial appendage and the aorta, which caused the hole in the hollowed model. Now let's go over to Mimics and take a look at the segmentation in the same region. We can see that there is the same false connection on the mask level. This could have been fixed during the segmentation process by taking advantage of an editing tool, such as multiple slice edit, before converting the mask to a part and bringing it back over to 3Matic. Another cause for false connections is when applying the wrap operation. Let's go back to 3Matic and compare the blood pool model before and after applying the wrap operation. Before wrapping, we can still clearly see the false connections from the segmentation, but after applying the wrap operation, we can see a significant increase in the volume of false connections. It is important to carefully consider the parameters used before wrapping, especially the gap closing distance and smallest detail parameters. With this example, I used a gap closing distance of 0 and smallest detail of 1 millimeter. Even though I used a gap closing distance of 0, the distance between the right atrial appendage and the aorta is so small that the smallest detail I chose was still too large and needs to be reduced. Sometimes going back and making adjustments to the segmentation or redoing the wrap operation can be very time-consuming, especially if you have already done other modifications to the model, such as smoothing, cutting, or adding a label. This is because you would also likely have to redo those steps in addition. I will now focus on walking through some easy steps on fixing these holes to avoid having to go back and redoing a majority of your work. The first thing we are going to want to focus on is isolating the region of the model that contains the holes we want to fix. This is to ensure that we don't make any unnecessary edits on other parts of the model. There are a few ways we can consider isolating the region with the holes. The first is applying sectioning to our model. This will allow us to crop our model along an already existing plane, whether that be X, Y, or Z, or a user-defined plane. I'm going to define my own plane by creating a datum plane under the Design tab. Once I've placed and applied my plane, I'm going to go over to the properties of the plane and select Section View. I am then going to select Create to add it to my list of section views. This will allow me to now drag the plane along the model to be able to better visualize the holes from a different angle and hide parts of the model that we don't want to edit. After sectioning, we can take it a step further and use rectangular clipping to hide the rest of the model. I want to note that this is not deleting the surrounding model or the triangles, but rather making them invisible. This helps to optimize the editing process for previous reasons discussed. Now that the holes are isolated, we can focus on fixing them. There are multiple hole filling tools in 3Matic, but the input requires the hole to have a contour around it. To create the contour, I'm going to select the Mark Wave Brush tool and mark the region around the hole. I'm going to make sure to hold down the Shift key while marking to ensure that the selection goes all the way through the screen and marks both sides of the hole. This will create a selection of marked triangles in orange. I'm going to right-click on the folder of marked triangles in the object tree and delete this folder. You will now see a contour surrounding the hole. I'm going to go through the same process with the two other holes. Once I've created contours around each of the holes, I'm going to use the Fill Hole Freeform tool to fill in these holes. Once I've applied this tool, you will notice that each of these newly filled holes are now their own surface. We can merge all of these surfaces together to the main model. To do this, I'm going to go to the object tree, open the surface list, right-click, and select Merge All. Once the editing is complete, we can make the triangles visible again and turn off the section plane to see the full, newly fixed model. This concludes the tutorial on fixing holes and false connections to ensure anatomical accuracy of the model. Thank you for watching.